So now we are coming on next topic of on trigonometry, sign of trigonometrical functions. Sign of trigonometrical function means we should decide. We have already done 6 trigonometrical function. One is sine theta, cos theta, tan theta, then cosec theta, sec theta, and then tan theta already gone, so it's cot theta. So these are the trigonometrical functions we have already done. And now we have to decide which trigonometrical function in the quadrant, different quadrant will be positive and which will be negative. Means for example, if I go from here to here, I say it will be 0 to 90 degree, then 90 to 180, 180 to 270, 270 to 360. Then in when the sine 30 degree if I take, so 30 degree means first quadrant. Sine 120 goes in second quadrant. Sine 220 goes in third quadrant. Sine of 290 that will be going in fourth quadrant. So we should find out where the sign will give plus value to you, where it will give minus value to you. Till now you have only done first quadrant. In 10th class you have only done about the first quadrant values, and all values you got that is either infinity or it is positive. So now my question is how we decide that where this trigonometrical function will be positive, where this will be negative. So that thing we have to decide now. So for this, let us start with this triangle, because this is a complete circular system we are taking. So first thing we should know that here the angle is 0 degree, and one thing more you should keep in mind, 0 degree, or it is also called as 0 radian. Here the angle comes out to be 90 degree if you take in degrees, but when you take in radians, so 90 into pi by 180 will convert as radian. So it will be pi by 2 radian here. So whenever I'll write now 0 radian, this is pi by 2 radian, or you should say 90 degree. But in degrees now we are not going to use, we are going to use in circular system, so it's pi by 2. Here when you reach this angle come out to be 180, and when 180 is there and if you convert this in radian, it will be coming as pi radian. This angle will be either 180 degree or it is pi radian. Same way when you go for it, the angle is 270 degree here, or it will be 3 pi by 2. Same way here when you go back, it will be 360 degree or it will be 2 pi radian. So this you know how to convert it. So now we have to find out which trigonometrical ratio will be positive, which will be negative. So we are concerned about mainly 3 trigonometrical ratios. One is sine, another is cos, another is tan. And then remaining are their reciprocals. Only the reciprocal will does not matter in taking sine of the trigonometrical. If sine is negative, automatically cosec will be negative. Cot is positive, then tan is also positive. So that way you can go. So here in this case, first let us consider this is one point P. One more thing I am taking here, circle we have taken, that circle will be with unit radius. It is not a compulsion, but only for our convenience. To make our calculation simpler, we are using this as a unit circle. And I told in the beginning that radius of the circle does not decide your angle. So that's why we are taking simply this length will be 1. And let this angle come out to be theta. When you think about this P point, let the coordinate be x comma y. When you think about x comma y, then I'll draw a perpendicular here. When you draw a perpendicular here, this part will be x here, this part will be y here. And in the first quadrant, one thing is already known to us, that is x is positive and y is also positive. This is for first quadrant. When your line rotates, it reaches somewhere here. This angle will be 90 plus theta, or we have gone in second quadrant. When we go in second quadrant, this point will be, let it is coming Q. Then in this case, when you take this angle, then in this case, the coordinate of this come out to be minus x comma y, because x will be negative in this case and y will be positive in this case. Then when your angle goes here, that means your rotation goes like this. In that case, if you take here, again if I am taking this point P here, then this will be, let it will be r, and this time the coordinate will be minus x comma minus y. And same way when you go here, when the angle goes this way, complete round, this coordinate will be x will be plus and y will be minus. So now when you take in first quadrant, when the angle goes in first quadrant, if you think about sine theta, it will be perpendicular by hypotenuse. So is it y by 1? Same way we'll take cos theta, it will come x by 1. Tan theta, that will be coming perpendicular by base. This is perpendicular by base, this will be perpendicular by hypotenuse, this will be base or hypotenuse. After getting this, now in first quadrant when we are thinking, first quadrant, when your angle is in first quadrant, you know x and y both are plus. X and y plus means sine theta is y by 1, 1 is already plus, y is also plus, so we will say this will be a positive number. Same way when you take cos theta is x by 1. In this case again it is in the first quadrant, value come out to be greater than 0. Because x is positive, this is 1. Same way tan theta when you take it will be y by x. When you think about y by x, y is also plus, x is also plus, so this come out to be greater than 0. So in this case, when you take in first quadrant, all the trigonometrical ratios will be positive. Sine 30, cos 30, tan 30, cot 30, sec 30, cosec 30, whatever angle, whatever trigonometrical ratio you take, and if the angle is in the first quadrant, we will say all will be plus. Sine theta is here, then if you think about cosec theta, it will come 1 by y. This is also positive. Then sec theta when you take, it will be 1 by x, it is positive. Then we'll say cot theta, that will be again x by y, coming positive. So we will say all positive in first quadrant. So whenever angle goes in first quadrant, we will say all trigonometrical ratios will be positive. All trigonometrical ratios will give you positive values if it is taken in first quadrant. Same way if I go in second quadrant. Now I'll think about second quadrant. Second quadrant, when you think, these are the values remain same. In this case, sine theta, is the y positive here? When you go in second quadrant, your angle is gone this way, so it will be gone in second quadrant. Second quadrant, the coordinates are x and y. X is negative, y is positive. If y is positive means this will remain positive. X is negative means it will remain negative. Y and x, y is positive but x is still negative. So one positive, one negative. This is we have positive, this we have negative. So net is negative. Same thing here. It is positive, it is negative, it is negative. So here what you will find in this case, in the second quadrant, sine and cosec positive. Sine and cosec. Sine and its reciprocal. They are positive. Other are what? Cos, sec, tan, cot. All will give you negative. So keep in mind in second quadrant we have sine positive and its reciprocal positive. So here we should say sine positive, here we should say all positive. Then we go for third quadrant, when the angle gone in this quadrant. When you go for this, in this case x and y both are negative. When x and y both are negative, what changes will be here? Just check. Y is negative, so it is negative because 1 is always positive. Hypotenuse can never be negative because hypotenuse, how you calculate, it will be coming under root of x square plus y square. It never come out to be negative. So it is negative, x is also negative. Here what you will say, y is negative as well as x is negative. So net come out to be positive. In this it is negative, negative, and here it come out to be positive. So in quadrant number third when you think, sine theta is negative, cos theta is negative, tan theta is positive. So what I should say in this case, third quadrant when you say tan and cot will be plus. Tan and cot theta, they will be positive. Another one left is sec, cosec, sine, cos. They all will be negative. So here we should think about third quadrant, it will be tan plus. So tan theta come out to be positive in quadrant number third. Then we think about fourth quadrant when you take the angle more than 270. So it is gone here. In this case, x is positive, y is negative. So just check here what conditions comes. In this case, when you think about the fourth quadrant, what I get here, y is negative. So this will be negative. This is also negative. X is positive. So it is positive. It is positive. Here what you will find, y is negative. This is positive. So it will come out to be negative. Here also it will be plus and minus. So it will be coming negative. So which will be plus here in this case? We have plus is what in fourth quadrant? Only cos and sec are plus. Other are negative. So cos and sec, they are positive, other are negative. That is tan, cot, sine, cosec, they all will be negative. So now you should know one standard result. Directly you can remember. This is the method I told you how you got this, which one is first quadrant, which is positive, which is negative. So you got that. But now you can remember this directly and you got one result here. What that result says, this will be the first quadrant, this will be second quadrant, this will be third quadrant, this will be fourth quadrant, this will be x and x dash, this will be y and y dash. In first quadrant, all trigonometrical ratios will be positive. In second quadrant, sine and is reciprocal. Whenever I write sine, cosec is understood. So sine is positive here. Third quadrant, tan is positive. And fourth quadrant, we have cos is coming positive. So in this case, now you should remember one word which will help you. A, S, P and C. What A stands? All positive in first quadrant. Here it says sine is only plus. Sine and its reciprocal. Here stand for 10. Third quadrant, it will be 10 coming positive or cot coming negative. Positive, sorry. And here it comes cos positive or sec positive. So all sine, tan, cos. First quadrant all positive, second quadrant sine positive, then tan positive, then cos positive. So all sine, tan and cos. This way we have four quadrant and they are deciding which trigonometrical ratios will be positive and which will be negative. So that you can calculate easily. So all sine, tan, cos. Or you can remember this way, all school to college. This word if you remember, you will remember ASTC, or I think better will be ASTC you should remember. How we will apply this or how we are going to help, how this result is going to help to get the values here, we should know that. So first example I am taking here. This question says you find out what is sin x and what is tan x if cos x is given minus 12 by 13. One thing we should keep in mind first, cos is given negative value here. Cos negative, where it is just you should identify. Cos is positive here. Here it is positive, all positive. So cos will be negative in the second quadrant, in the third quadrant. I told this is 0. This will be pi by 2. This is pi. This will be 3 pi by 2 and this is 2 pi. Now this you should remember in terms of radian. So here we will say in this case two possibilities are there. Case 1. When x is the angle we have, it is in the quadrant number 2. That is pi by 2 to pi. Case 1, when x is between pi by 2 to pi. That means it is which quadrant? Pi by 2 to pi means second quadrant. We have to decide where it is. If they mention, it's okay. Otherwise, we have to decide. As it is coming negative, we should say it will be either in second or in third. So I've taken cos x is minus 12 by 13. So case 1 says x is between pi by 2 to pi, or it is in the second quadrant. Now I should find out what is sin x and tan x. So when you think about sin x and when you think about tan x, sine will be perpendicular by hypotenuse. Sine in second quadrant, as we are considering the second quadrant, sine will be coming plus, and it will come out to be perpendicular by hypotenuse. Tan will be in the quadrant number 2 will be minus, because we are taking second quadrant, so it will be minus and it will be perpendicular by base. So only the thing is we should know what is perpendicular, what is hypotenuse, everything will be known to you. So here in this case cos x is given, so I create a triangle here. Without seeing the sign, minus only indicate that it is gone in second quadrant. Minus is indicating it is in the second quadrant. So here in this case, if it is taking this triangle, this is x we have, and in this case cos is what? Base over hypotenuse. And if it is hypotenuse and this is base, perpendicular come out to be 5. Then directly you can write what is sin x. Sin x will be what? Perpendicular by hypotenuse. Perpendicular is 5, hypotenuse is 13. So I should say answer is 5 by 13. Same way when we think about tan x, clearly it is coming minus. When it is coming minus, what it shows? Perpendicular upon base. Perpendicular upon base. Perpendicular is 5 and this is 12. So I got the value of sin x. When it is in the second quadrant, sin x will be plus 5 by 13 and tan x will be minus 5 by 12. And then now coming on second case, case 2. It can go in third quadrant also. When it go in third quadrant, what I should say in this case, case 2, x is between pi to 3 pi by 2, third quadrant. And when you think about third quadrant, now there is a slight change. What change is here? Just check. When you think about third quadrant, sign will be minus. What about 10? 10 will be plus. Perpendicular hypotenuse, that will remain same. So it will come minus. Perpendicular is what? 5. Hypotenuse will be 30. 10 will be perpendicular by base. So this way you get the answer. So we will say tan x, this is sin x. Tan x. So sin x we got minus 5 by 13, third quadrant, and 10 come out to be plus 5 by 12 because it's already plus, so plus 5 by 12. So it become reverse now. At this stage, tan will become plus, sin will be minus. Here sin was plus, tan was minus. So this way you are going to get the angles. Next time we'll continue.